Hello friends, this is Amit Bhuttani, Assistant Professor in Mechanical Engineering Department at Dr. Subhash Technical Campus, Junagadh. I welcome you all in the presentation related with the subject Operation Research. So this is our fourth lecture related to the subject Operation Research, and the chapter that we are discussing, that is transportation problem. So this is the fourth lecture in which we will study about the topic that is Vogel's approximation method. So let us start our discussion with Vogel's approximation method. In our previous lecture we had studied about least cost method, which is used to obtain the basic feasible solution. So totally there are three methods which are used to obtain the basic feasible solution. The first method, that was northwest corner method, and in our third lecture we have discussed about least cost method, and in this particular lecture we will discuss the last method, that is Vogel's approximation method. It can be said as a WAM method also. So what is this method? This method is also used to obtain the basic feasible solution. It is also known as a penalty method. It is preferred to the other two methods. Yes, this method is mostly preferred as compared to the previous two methods, that is northwest corner method and least cost method, because it gives you a solution which is almost nearer to the optimal solution. So in this particular chapter, transportation problem, our main objective will be to minimize the total cost of transportation and to obtain the optimal solution. So to obtain the optimal solution, the first step will be to obtain first of all the basic feasible solution. So there are three methods: northwest corner method, least cost method, and this WAM method, which will be used to obtain the basic feasible solution. But this method is mostly preferred because it gives you a solution that is almost nearer to the optimal solution. For optimal solution also there are two methods that we will study in the upcoming lectures. So this method is preferred. It is also known as penalty method, and it is preferred to the other two methods. Then in this method, each allocation is made on the basis of opportunity or penalty that would have incurred if the allocation in certain cells with minimum unit transportation cost are missed. So in this method, how the allocation is done, that is made on the basis of penalty cost that would have incurred if you have missed the allocation in certain cells with minimum unit transportation cost. So that we will see in the example, that will give you a better clear idea how to solve this example using this method. Don't worry about this step. This step will be explained very nicely in the upcoming slides in the example itself. So what are the steps that is required to be followed to solve the examples using WAM method? So the first step that will be required, that is calculate the penalties for each row and column by taking the difference between the smallest unit transportation cost in the same row or column. So first step is to calculate the penalties for each rows and columns by taking the differences between the smallest unit transportation cost in the same row and column. So there are three rows and for example there are four columns. So suppose for the first row, if you need to calculate the penalty, then if in the first row there are three elements 12, 15 and 17, so you have to take the differences of the two smallest values, that is 12, 15 and 17. The smallest is 12 and 15. So take the difference of 15 and 12, so that will give you 3. So the penalty for the first row that you have calculated, that will be 3. Accordingly, for the columns also you will have to calculate the penalties between the smallest unit transportation cost in that same cell and same column. So for each row and for each column you will have to calculate penalties. How that is obtained? That is obtained by taking the difference between the smallest unit transportation cost in that particular in that particular column or row. You will have a better understanding in the examples itself. So this difference indicates the penalty or extra cost which has to be paid if one fails to allocate This difference indicates that extra cost has to be paid if one fails to allocate to the cell with minimum unit transportation cost. Next, identifying the row with the largest penalty. Identifying the row with the largest penalty and allocating the maximum possible with the largest penalty and allocating the maximum possible quantity to the lowest cell in the selected row or column, so as to exhaust either the supply at a particular source or satisfy the demand at warehouse. So once you have calculated in your first step the penalties of each row and each column, now the second step is to identify the row or column with the largest penalty. So in whichever row or in whichever column you find that row or column is having the largest penalty, that you need to identify and allocate the maximum possible quantity to that lowest cost cell in that particular column or row. So suppose for example you have calculated the penalties of each row and each column. Now you come across that the first column is having the largest penalty among all the rows and among all the columns. So that first row is having the largest penalty. Now you just need to allocate the maximum possible units quantity to the lowest cost cell in that selected column. Suppose that column is having three values, 12, 15 and 17. So first column is having 12, 15 and 17 value. So the lowest cost cell is 12. So you need to allocate the maximum possible quantity to that lowest cell of the selected first column. This is your second step. Third step, if a tie occurs in the value of penalties, select that row or column which has minimum cost, and if there is a tie occurring in the value of penalties, then select that row which has minimum cost, and if there is a tie among the minimum cost also, then select that row in which maximum possible assignments can be done. So this will be better understood in the examples. Fourth step, adjust the supply and demand and cross out the satisfied row or column. So whichever row or column is exhausted or satisfied, you need to delete it or cross out. If a row and column are satisfied simultaneously, only one of them is crossed out and remaining row is assigned zero supply. Any row or column with zero supply or demand should not be used in computing future penalties. Yes, so whichever demand of the warehouse or supply capacity of the source is zero, that will not be used for computing further, and their penalties will also not be calculated in the next steps or the computation process. Next step, recompute the row and column difference for the reduced table and omitting rows and columns crossed out in the preceding step. So in the previous step, when you find rows or columns that was crossed, you did not need to draw it in the next step. That row will be omitted or column will be omitted, and again calculate the row and column difference for the new reduced table. Again you will have to calculate the penalties. Next step, repeat the steps from 1 to 4 until a feasible solution has been obtained. So what is feasible solution? Feasible solution is nothing but which satisfy the constraints of supply, constraints of demand. Then Xij is greater than or equal to 0, that is non-negativity constraint, and rim conditions. Rim condition is nothing but supply and demand should always be equal. So these all conditions, these all constraints are satisfied, then it is said to be having a feasible solution. So until the entire supply at various source are exhausted to satisfy the demand at different destinations. So this was the steps that will be used to obtain the solution using WARM method. So let us calculate one example for your betterment and for better understanding. This is the example that we will calculate. Example and the data. First of all, let us try to understand the data. Use WARM to obtain the basic feasible solution to the given transportation problem. So this is the problem that is given to you. This data is same that we had used in the least cost method also, and as well as in northwest corner method. The data remains the same. So this is the table that is given to us. This much things will be given. Factory, there are 3 sources, F1, F2, F3. There are 4 warehouses, W1, W2, W3, W4. Its requirement is given and source capacity is given at the end of each row, and demand of each warehouse is given at the end of each column. So this 21, 16, 25, 13, 17, 18, 14, 23, 32, 27, 18, 41, these all are the CIJ, that is unit cost of transportation from ith source to jth destination. So how can you read this 21? So 21 is unit cost of transportation from source F1 to destination point W1. From F1, if you are moving it to the warehouse W1, its unit cost of transportation is 21 rupees. Simple. Similarly for F1 W2, for F1 W3, and so on. Now, to save our time, I have already only this much table will be given till requirement. This column penalty and row penalty you will have to calculate separately. So for not wasting more time, I had calculated it over here. You will have to calculate the row penalty and column penalty. So that can be drawn over here, but I have not drawn because to save time. So how to calculate the row penalty and column penalty? So you can see for source F1 the capacity is 11, for F2 it is 13, for F3 it is 19, and this 43 is supply is equal to demand, so that is rim condition. Now to calculate the penalty of row F1 for the first row, what you need to do, okay, there are 4 values 21, 16, 25 and 13. So you will have to take the difference of the 2 cells. First of all, the cell with the lowest value is 13, then next cell with the lowest value is 16. So taking the difference of the 2 lowest value in that particular row, that is 13 and 16, when you take the difference of these 2 values, that will give you 3. Same procedure for row 2. Identify first the lowest value in that particular row, that is 17, lowest value in row F2 is 14, and second lowest value in that particular row is 17. So taking the difference of that 2 will give you the penalty of F2 row, that is 3. Now for row F3, identify the cell with the lowest value, that is 18, and second lowest value is 27. So when you take the difference of 27 and 18, you will find the row penalty of row number 3, that is F3, and that is 9. Now column penalty is also found out with the same procedure. For column W1 there are 3 values 21, 17 and 32. So the lowest value in that particular column is 17 and second lowest value is 21. So taking the difference of 17 and 21, that will give you 4. Similarly for column W2, first of all identify the column which is having, for column W2 identify which cell is having the lowest value, so that is 16, and second lowest value is 18. So when you take the difference of these two, 18 and 16, you will get 2. Same procedure for W3 and same procedure for W4. So this is how you are calculating the penalties of rows and columns. Why you are calculating these? You might have a question, why you are calculating these penalties? Ultimately this WARM method is a bit time consuming method, but it will ultimately help you to get your solution more nearer to the optimal one. That's why this method is more preferred as compared to other two methods. So why you are calculating the penalties? that we will see in the next slides. Calculate the penalties for each row and column by taking the difference between the smallest unit transportation cost in the same row and column. So that is what I have explained you. Then from the above table we can see that penalties of each rows and columns are found. Yes, we had found out how to find out, that I have already explained. Second step, now identify the row and column with the largest penalty. Now what is your second step? So once you have calculated in your first step the rows and penalties, the penalties of rows and columns, now your task is to identify which row or column is having the maximum or the highest penalty or the largest penalty. So you can see the column with the largest penalty, that is 10, this one, and allocate the maximum possible quantity to the lowest cost cell in that selected column so as to exhaust either the supply or satisfy the demand at warehouse 4. So again I have drawn the table over here, and you can see that the column 4 is having the maximum penalty, that is 10, from all other penalties that you have calculated for the column as well as for the row. For row it is 339, for column it is 424 and 10. So 10 is the maximum penalty or the largest penalty among all that we have obtained. So we will select that column for doing the allocation. So we have selected this column W4. Now how to do the allocation? So there are 3 elements in the column W4, 13, 23 and 41. So the cell with the lowest cost that we will select to do the allocation. So we have selected 13. Now the requirement of warehouse W4 was 15 and the capacity of factory F1 was 11. So from 15 and 11, whichever is the smallest that we will allocate, and that is 11. So now you can see F1 factory's capacity is exhausted and it becomes 0. So now we will delete this F1 factory in our next step, and we will redraw the table. The reduced table will be in the next step that we will see in our next step. So now still 4 remains. So now factory F1. So same procedure is followed. We will redraw the table in our next step. That is our reduced table, in which F1 row will be omitted. Remaining all the things will remain as it is. And again we will have to calculate the row penalty and column penalty that we had seen in our first step. Same procedure will be followed. So recompute the row and column difference for reduced transportation matrix or table and omitting F1 row. So F1, you can see in this table F1 is omitted, rest of the things are as it is. F2, F3, those values are as it is. Now again calculating the penalty for F2. So F2, the smallest is 14 and second smallest is 17. So difference will give you 3. For row F3, the smallest value is 18 and second smallest value is 27. So if you take the difference of 27 and 18, that will give you 9. Now for columns, for W1 there are 2 values, 17 and 32. So if you find the difference, that will give you 15. Then for W2, 27 and 18, difference is 9. So that is penalty for column W2. Similarly for W3 it will be 4 because there are 2 elements, 14 and 18. So if you take the difference, then it will be 4. And for W4 the difference of 41 and 23 gives you 18. Now the requirements are 6, 10, 12, 4 that was remain in our this previous step, that is written over here, and 13 and 19. Now again checking which penalty is higher. So in row F2 the penalty is 3, in F3 it is 9, for warehouse W1 15, warehouse 2 it is 9, 3 it is 4, and for warehouse 4 it is 18. So the largest penalty is found out in the column, that is W4, and that is 18. So we will select that column for doing the allocation. Now from the 2 values 23 and 41, whichever is the smallest, in that we will do the allocation. So 23 and 41, the smallest is 23. So we will do the allocation over here. Now selecting how many values that can be allocated. So from the requirement you can see from W4 for W4 the requirement is 4 and the capacity of F2 is 13. So from 4 and 13 whichever is the smallest that we will allocate. So we have allocated 4 over here. So you can see now warehouse 4's requirement, that was 4, that is satisfied. So that's why we will delete this W4 and we will redraw the table in which we will omit the column W4. So now factory F2 will remain with only 9 capacity, F3 that is as it is, that value is 19, and W1 will be 6, 10 and 12. Checking the rim condition, 9 plus 19 that is 28 and 6 plus 10, 16 plus 12, 28. So rim condition is also satisfied. Moving to our next step, we will redraw the table in which we will omit W4. So from table we can see column W4 has the highest penalty among all and allocating the maximum in the lowest cost cell in that column. So now W4 required is satisfied, so deleting the column and redrawing the reduced table in our next step. So this is our next step in which W4 is omitted. So there remains 3 warehouse, W1, W2 and W3. The requirements were 6, 10 and 12. F2 and F3 all the cell values that was as it is and we had kept that as it is. The capacity of F2 was 9 and 19. Now again calculating the penalties, the same procedure will follow for row and column. So for row there are 3 elements, 17, 18 and 14. So the smallest value in the row F2 is 14 and second smallest is 17. So if you take the difference, that will give you 3. Same procedure for row F3, the smallest value is 18 and second smallest is 27. When you take the difference, you will get the row penalty for F3, that is 9. Similarly for the column penalties, there are 2 elements in W1, 17 and 32. So the difference of that 2 will give you the penalty of W1 and that is 15. Similarly for the warehouse W2, the difference will give you the penalty and that is 9, and for W3 column the difference is 4. So that is the how the penalties of column is calculated. Now what is the procedure to do the allocation? First of all, you need to identify the row or column with the largest penalty. So for F2 row the penalty is 3, for F3 row that is 9, for W1 column that is 15, for W2 column that is 9 and for W3 column that is 4. So among all these, the column W1 has the largest penalty and that is 15. These are the steps that I have already explained how to. So that column will be selected for doing the allocation. Now from where to do the allocation, that is to be understood. So there are 2 values in that particular column, W1 and in W1 that is 17 and 32. So the smallest cell or the column with the smallest value, that is 17. So we will do the allocation over here with the lowest cost. Now you can see the requirement of W1 was 6 and the capacity of F2 was 9. So from 9 and 6, whichever value is the smallest, that we will allocate in this particular cell. So that is 6. So you can see now, okay, warehouse W1's requirement was 6 and that is satisfied. So we will delete this W1 column in our next step and we will redraw the table. So it will be our reduced table, but still now the capacity will remain 3. The capacity of this factory F2, that remains with 3. Still they can supply 3 units. Moving to the next step, reduce table in which we are deleting this W1 column. So now remains 2 columns, W2 and W3. F2, the values of F2 that we had put, that is as it is. Now the capacity of F2 from our previous step, that was 3, that was remaining with F2 factory that we have put over here. Then for F3 it was 19. The requirement of F2 was 10 and 12 that we had put over here, 10 and 12. Now again calculating the penalties, the same procedure. F2, that is difference between 2, so 4. difference between these two will give 9, difference between these two will give you column penalties, that is 9, and difference between these two, that is 4. So now you can see there is a tie among the penalties, because you cannot identify here which row or column is having the largest penalty. For second row F2 that is 4, and for third row that is 9. Similarly for second column that is 9, and for third column that is 4. So how to select now when in case of a tie? How to move forward in our example when there is a tie among the penalties? So as we see, there is tie in the value of penalties between column W2 and row F3, because the largest penalty is 9, that is in F3 column, that is in F3 row and in W2 column. Both are having the same value, that is 9. And also there is tie among the minimum cost. So when there is tie among the penalties, then what you need to do? You need to identify the column or row with the lowest cost. So if you go through this column, the lowest cost is 18 and the lowest cost among 18 and 27 is 18. So if you do allocation over there, then also it is possible. But if you see for the row that is having penalty 9, and if you see there also their lowest value is 18, so there is also a tie, and also there is a tie in minimum cost. In this column W2 the lowest cost is 18, as well as in the row the lowest cost is also 18. So again there is a tie among the minimum cost. So now how to do the allocation? So now the allocation can be done. How you will do the allocation? This is very important. Try to concentrate more over here. So suppose I do the allocation over here, for example. So the requirement is 10 and capacity is 3. So the minimum value that can be allocated from 10. So from 10 and 3, which is the minimum that can be allocated? So I allocate 3 over here if I am selecting this. But if I go for this row having the lowest value, that is 18, so you check how much allocation can be done among this. So here the requirement of W3 that was 12, and here the capacity was 19. So from 19 and 12 the minimum value is 12. So now which to select for doing the allocation? As you had seen in this W2 column, the maximum allocation that you can do, that was 3, and in case of row, if you go for row, then the maximum allocation was 12. So from this 3 and 12, which allocation, in which the allocation can be done more, that value is selected. So 12 is larger than 3, so we will select this row for the allocation, because in this particular row we can do maximum allocation with 12 units. If you go with the column, then you can only do 3 units can be allocated. So now in this case you will have to select the cell in which you can do the maximum allocation. So now we will select row F3, because this we can make maximum possible assignments, and that is 12. If you had gone with this, then only you can do 3 allocation. But if you had gone with the row penalty, and that is having 9 value, so in that lowest cost cell in which you can do allocation of 12. So among 3 and 12, the 12 is maximum value, and maximum allocation is done in that. So that maximum allocation is given importance over here. So F3 and W3 is allocated with the value of 12. So now W3 is satisfied. You can see from the column its requirement was 12. We have already allocated 12. So W3 is satisfied. So deleting that column and redrawing the table for the next step, and that will be our reduced table. So moving to the next step, this is our reduced table. Now only remains the column W2. Still there are 2 factories, F2 and F3. In our previous we had seen factory F2 has still 3 capacity remaining. Once we have allocated 12 over here, now factory F3 remains with 7 capacity. There was total 19 units that can be allocated, but we had already allocated 12, so now the supply capacity of F3 will be 7. That we will write in our next step. So this is the capacity of F3. Now there are no other columns that is available, so row penalties will be dash. Column, if you find the penalty of column, that is difference between 18 and 27, that is 9. So now how to do the allocation? So from 18 and 27 in the column W2, the cell with the lowest value for doing the allocation, the column W2, the cell that is having the lowest value will be selected for doing the allocation. So among 18 and 27, the lowest cost cell is this 18. So we will do the allocation over here. Now the requirement of that particular W2 is 10 and supply capacity of F2 is 3. So from 10 and 3, the minimum value will be used to allocate. So 3 is allocated over here. So now you can see factory F2's capacity, that was 3, that is now exhausted, that is now 0. So we will delete F2 row in our next table and we will redraw the reduced table in our next step. But still the requirement of warehouse 2, that is 7, that is still remaining. So that we will draw in our next table, that is the 7th step, reduced table. Now F3, that's 27, it is as it is. Still W2's requirement was 7 and supply capacity of F3 that was in the previous table, that was 7, that was still there. So both requirement is also 7 and supply capacity of F3 is also 7. So we will allocate that value in this cell F3 W2, that is 7. So you can see W2 requirement is satisfied, so that is 0, and at the same time F3's supply capacity was 7, so that we have already allocated to this warehouse, so its supply capacity is also now 0. So it is completely exhausted. So we can say now all the factory's capacity is exhausted and at the same time all the warehouse requirement is satisfied. So we will stop now the allocation process, because each and every factory's capacity is exhausted, at the same time all the warehouses requirements are satisfied. Next. So everything is now completed. Now I will again redraw the table that was given in the data, in which I am not showing now the column penalty and row penalty. So this was the data that was given to you in the example. This will be given to you. Now we are just putting the allocations where we had obtained in the procedures or in the steps that we had used to solve the examples. So this was allocated in this F1 W4, we had allocated 11. This allocation for this cell F2 W1, that was 6, F2 W2, that was 3, F2 W4, that was 4. So you can see F1's capacity is 11, so that is used over here, that is satisfied. For F2, its capacity was 13, so it was allocated 6, 3 and 4, so that is 13. For F3, we had seen the allocation. For F3 it was 7, 12, so 7 plus 12, that is 19. Similarly, you can check warehouse W1's requirement was 6, so that is allocated accordingly. For W2, the requirement was 10, so that is allocated accordingly and that is also satisfied. W3's requirement was 12, so it is allocated accordingly and it is also satisfied. And W4's requirement was 15, so that is also satisfied according to the allocation shown in the table. So this is the final table along with the allocations that we had obtained. So this, all the values that is in the circle or rounded, that is the number of units that has to be transported, Xij, these are Xij, that is the number of units transported from ith source to the jth destination. So how can this be read? This is F1 and W4. So from F1 factory to W4 warehouses where the requirement, this number of units is transported, number of units that is transported, that is 11. So the basic feasible solution is 1, which has m plus n minus 1 non-negativity allocation. M stands for row, n stands for column. So we had done, and we can see from the table there are total 6 allocation, 1, 2, 3, 4, 5 and 6. So this is having 6 allocations, and this problem is said to have basic feasible solution. Now finding out the total transportation cost, 13 into 11, this 13 is the unit cost of transportation, this 11 is number of units that can be transported among ith source to jth destination. This is 17, this is 6, this is 18, this is 3. So if you do the calculation, you will get 796. That is the total cost of transportation. So if you check the total transportation cost obtained by all the 3 methods, this method will give you the minimum cost, and this will also help you to obtain the optimal solution, almost nearer to the optimal solution. This method will help you to obtain nearer to the optimal solution. So where xij is the number of units to be transported from ith source to jth destination. So here I is equal to 1, 2 and 3. Ith source means there are 3 sources, F1, F2 and F3, and jth destination means warehouse W1, W2, W3 and W4. So j is equal to 1, 2, 3 and 4. This value is shown in bracket. Now Cij is the unit cost of transportation from ith source to jth destination. This is Cij. Rounded value is the number of units that is transported from ith source to jth destination. So how you can read this? F2. So to transport from F2 to W1 warehouse is 6 units can be transported between F2 and W1. So this is all about this method. I hope this would have helped you to understand the Vogel's approximation method, which is used to obtain the basic feasible solution. Thank you.